All right, we're going to go ahead and get started. Thank you all for joining us here. I'm Ashar Chaudhary. My colleague here is Eric Krenz. We are at Target, and we're going to talk about REDstack today. So kind of laying out our presentation here real quick, we're going to start out by talking about big data at Target and what our environment looks like, multi-tenancy and the implications of that. Start of the product, initially it was called Pushbutton. We'll talk a little bit about that. And how we do full stack testing, our early adopters, and then how we added Elasticsearch and Druid as part of our product offering on top of Hadoop, continued development, our state where we're at right now, and how we open sourced it back in December 2017. All right. So big data at Target. At Target, we have a very large Hadoop implementation with thousands of nodes. I also want to add this is a single multi-tenant cluster that presents some of its own challenges that Eric is going to talk about in a little bit more detail in a little bit. And we have had a very rapid growth of our Hadoop environment. Like most organizations, 5 or 6 years ago, we started with a small Hadoop setup. Since then, we've had a very rapid growth. We've added hundreds of nodes per year, and currently we're up in the thousands of nodes for our cluster. One of the things that we really take pride in is that our implementation at Target is completely open source. We have the source code for everything that's deployed on the cluster, and we manage it all with our internal engineering efforts. Data on our Hadoop cluster is a very significant footprint. Our data consists of all sorts of enterprise data, ranging from guest data. At Target, we call our shoppers guests. And inventory data, sales data, digital data, web, social media, mobile, all that stuff does come to Hadoop in some shape or form. We also have multiple frameworks and tech stacks, such as 2 concurrent versions of Python, 2 versions of R, and we're also supporting 4 concurrent versions of Spark on the same cluster. And as far as Python and R packages go, we use a lot of different packages to support our data scientists. We have over 100 packages that our data scientists use. And other stacks such as TensorFlow and Keras are also implemented for machine learning. These are all fully production supported by our own internal engineering efforts. Our environment is also very heterogeneous. We have a significant footprint of GPUs. We have hundreds of GPUs that are part of the same Hadoop cluster that are used to support significant workloads and several data science use cases with very heavy workloads. We recently also rolled out a GPU workload management solution, which was in-house, which our data scientists like a lot. It gives them a lot of ability to scale up, scale down their jobs, and go as they need to process their workloads without any intervention from our team necessarily. From a user standpoint, we have thousands of users ranging from data scientists to application teams and individual users who are running all sorts of jobs. And as far as daily job count goes, it's a significant footprint. We have over 60,000 daily jobs running on the cluster. And the data size is hundreds of petabytes and is still rapidly growing. So this is a quick overview of where we stand at Target for our Hadoop implementation. And we're going to move on to multi-tenancy and implications of that.
All right, so the majority of this talk is going to be about kind of how we kind of address the issue with us having kind of a very large single scaled out cluster and how we deal with the multi-tenancy and the implications that come along with that. So as you guys can imagine, as an environment gets larger, certain things get harder. Things are generally going to move slower in a larger environment. It's going to be very sensitive to change. Anytime you're going to make some kind of an upgrade, you have to be very aware of what kind of production workloads are running every single day and how that can affect users, and making sure any changes you make are effectively communicated to everybody using the platform. Adding new software and libraries can take time. It needs to be tested and fully run through dev stage prod. Make sure the users are going to be happy with it by the time it comes out. Upgrading versions in the cluster, something like an HTTP upgrade, even a minor one, can be incredibly intensive and time-consuming. And it's very difficult to practice, especially at this kind of scale, especially given that we don't have anything that can support this amount of hardware for us to run some kind of a usability test on prior to an upgrade. Users, I guess, find a lack of a kind of like a development environment that they can play around with. We have a stage cluster that we have open for testing, but still users who are trying to develop something out are always having to be aware of other users on the cluster and how their work can impact them. And then basically just trying to learn sandbox use cases that doesn't exist in this kind of an environment, because we only have these big clusters that are very production supported and have a very fine-tuned kind of workflow. So kind of, I guess 4 years ago, we started looking into ways to kind of solve that problem, kind of offer some kind of a sandbox that's really compatible with what we offer in production. So we originally started out with a product called Pushbutton. This was kind of the original Pushbutton Get Hadoop at Target. It served as a dev sandbox environment. It was a cluster of VMs that installed a 3-node Hadoop cluster, and that ran on our Target Macs. So it was basically just a specialized version of the Hadoop sandbox with some changes for our internal environment with Kerberos auth. It had a very similar stack to our prod environment, so we had the same versions of all software, and it had some problems though. Your Mac obviously has limited resources. It puts a lot of stress on your computer running that amount of stuff, and the biggest issue is that it can't be used by multiple users, and it can't stay running kind of when you put your computer away. So I guess something I'm also going to talk about is the history of how we've done kind of testing for our Hadoop cluster at Target. As you can imagine, it can be very difficult to test kind of. So as a background, we use Chef to manage our infrastructure. We have Chef recipes and roles for managing all of our control nodes, our data nodes. Because we just have one very large cluster, things like testing the control node recipe thoroughly all the way through become very difficult, right? So we have kitchen tests, but we don't feel like it's testing it well enough. What we want is some kind of an automated full integration build from scratch. So basically what we're trying to do is build an entire cluster from scratch and test it to verify that in the future, let's say we're adding data nodes to our production cluster, that will properly work and can go through without a hitch. So we built a product called REDstack using our internal cloud provider, which is OpenStack. We heavily utilized the OpenStack APIs to do things like set up all of the test nodes to mimic our production hardware as closely as possible. That does things like mimicking multiple disks mounted on each VM, making sure the OS looks identical. And by doing this, we were able to kind of utilize and pull in some of our infrastructure from Pushbutton, which we had developed and released earlier. So once this happened, we made sure we had ample resources for running and testing all the services in prod. So we did kind of a full smoke test suite across the new cluster. And this is kind of how we fully deployed an integration test at Target. And we've been doing this for a few years now, and it's worked great. But something we noticed that once other teams, like data science teams, data engineering teams who use our platform, we noticed that they would start to check out our code on Git and use it to build their own environments, right? So they kind of noticed that they could build their own cluster on their own OpenStack project and kind of have a mini prod cluster, right? So it came with identical cookbooks and a build process very similar to our production cluster. It had the same software configs and internal tools. And the biggest thing was that the cluster could be multi-tenant, right? So multiple people on a team could share the same exact cluster and do what they wanted to it, right? Because they had access to all the nodes and root access to everything without affecting other teams. But there were a lot of problems with it early on. It was obviously kind of built as a CI tool, so the build environment was very complex to set up. Only a certain amount of skilled data engineers were really able to get the environment set up, solve the dependency problems. There was a lot of dependencies on libraries and stuff that came with the application. So it was difficult to build. So we thought, I guess, as our team, why not turn this into a product? So basically something that could obfuscate all of these dependencies away from the user, make it very simple for them to just get their own set of quota from the OpenStack team and build that for them. So we started on the journey of building kind of out this product and started with a GUI. So we built a web GUI that would receive some basic information from the user. We wanted it to be as simple as possible, especially given that this would be kind of like a learning/sandbox environment for getting into Hadoop and big data at Target. So basically all we're really taking in is the OpenStack quota details, basically what's the ID of your provisioned quota, and then what kind of user credentials do you want, how many users do you want to have an account on this cluster. So once we get that, we feed it into our orchestration service called Stacker. Basically, Stacker is just a service that runs in the background, and it's building clusters constantly for users, basically just polling the OpenStack APIs, checking on the status of the build, running the chef cookbooks against that, and it uses their own provisioned OpenStack resources, right? So it's like fully owned and charged back to the user who wants that particular cluster. Along with this, stack ownership is going to fall completely on the user. It's their own resources, so we give them full root access to everything. Let's say they want to test out Zeppelin, and we haven't deployed that on our production cluster yet. If they wanted to, they could get REDstack, a mini version of our production cluster, install Zeppelin, start using that within their team. And then something we see pretty frequently is as a team will do that, and then they'll come back to us and be like, hey, we've deployed Zeppelin here. It looks like a really great product. Can you guys please deploy this in production? And then given the example that they've worked on, it's kind of a perfect kind of a proof of concept environment for teams wanting to do something like this on their own. Along with that, we don't provide support for the environments, right? If we're giving them root, they're not going to be officially supported by our big data platform team. We definitely provide support, but maintenance comes on the user if they're going to use it for anything beyond a dev or a sandbox environment. So as time went on, we've continued to add additional stack types to the cluster. So our team at Target, the big data platform team, we support a variety of different big data platforms. Elasticsearch has been a big one, and more recently we've really been getting into Druid clusters. So we've added both of these to REDstack. Basically from the same GUI, you can just pick an Elasticsearch cluster. It has multiple different versions you can pick from. Same with Druid, except Druid was kind of a special case where Druid can use basically an HDFS deep store. So when we built Druid, and this was very early on when Druid was first in early beta, we're able to leverage our existing REDstack cluster, the Hadoop one, pull out a bunch of the unneeded services like Spark, and just leave stuff like Zookeeper and MapReduce and Yarn, and then build that Druid cluster infrastructure on top of the existing Hadoop cluster, utilizing that existing Hadoop cluster, and then obviously tuned to what a Druid cluster would expect. So with Druid, we also offer multiple versions. So we have .11, .12, and the most recent, latest, and greatest. So people have really found that as a great environment for testing Druid. So as time went on, we've been able to refactor the core components in REDstack to provide real pluggability for the OpenStack provider. So obviously, the OpenStack team is continuously changing at Target as well as our team. So we need to continue to support multiple OpenStack versions, not just that single particular one we built for that testing use case early on. So we have it now such that any OpenStack provider can be used using the API that includes public OpenStack providers if you wanted to do something outside of Target. There's a lot of public clouds that just build out the OpenStack platform and then offer the APIs as public. So that's now a part of REDstack. We also now support all cluster sizes. So depending on what your project quota is, REDstack can support basically any size of cluster. And we built out algorithms for kind of really deciding what what kind of a cluster build to do based on these different project quotas that come to us based on what teams have needs for on their team. User management has become very easy. We've built out kind of a really friendly web UI for every cluster and a CLI for managing users. So let's say a team is leveraging a REDstack cluster for a Hadoop environment that they're testing with. If they want to add users after the fact, it's just a simple CLI, and it adds the user as a shell user on all the nodes. So they have SSH access, gives them kind of a Kerberos account, Knox, and then sets them up a home directory and also an HDFS home directory. So that's been really key in making this very user-friendly. We've also improved cluster management heavily. I guess the OpenStack historically hasn't always been very reliable. It's definitely gotten better, but we would see services kind of just go down for unknown reasons, connectivity losses. So we built out service monitoring scripts for REDstack and also admin scripts for, let's say, running a rolling restart on all the Elasticsearch or Druid services. That's now a part of REDstack. So I guess, how does it work? I'll kind of walk you guys through kind of the process of what a user would do. So a user is going to go to the OpenStack team and request a quota. So they're going to get X RAM, Y cores, and Z amount of disk. So once they do that, they're going to submit that quota to our stacker service, also provide any usernames and passwords for any users on the team who want to have access to it. The stacker is then going to analyze the quota, basically choose the best kind of cluster allocation for that. So how many control nodes are there going to be? How many zookeeper nodes do we need? How many data nodes should be in the cluster? How big should the disk be on each node, given that they just have a general Z amount of disk? How much do we want to put on the control nodes? How much should be on every data node? How many disks do we want? And how big are the nodes going to be? So once Stacker decides all this stuff, Stacker kicks off that build in a thread. And then once it's finished, an email is going to be delivered to the user with links to the cluster. So also on top of that, users can manage and rebuild their clusters from the UI. It is a sandbox, so let's say they horribly break it and they install something they don't want. A simple rebuild is just something you can click on and then it'll just wipe it, build it new from scratch. So I'm going to give you a quick look into kind of our user interface and then also kind of what that cluster web UI looks like. So let's see if this works. All right, so here's our internal dashboard for REDstack. As you can see, I've done many builds myself. So if you came in to build a new cluster, you would just come in here, kind of pick some of these are some internal OpenStack choices that you have at Target. You just put in your project name, which is going to be your quota ID, and then what you want to call it, your cluster name. So then you'd request the verification. It'd come back, tell you how big your cluster is going to be, and you can click build. I'm not going to do that right now, but I have one that's up here already. So this is what you would get back, kind of information like this in your email. You can see there's 14 nodes here, a maximum storage of 2,000 gigabytes, and it's 100% completed. So we can click on the link to the front end, and we can see kind of over here we've got the node, every IP of every node, so you could just SSH it from here. We've also got a name for all the nodes, and then we have links to all the relevant services in here, Yarn UIs, Hadoop UIs, and then this is a Druid cluster, so also the Druid UIs are here. You can see I can just open superset right here, and it should just be superset on the Druid cluster. Or I didn't actually expect the demo to work because a demo never works in person. But basically, there's going to be a link to everything in here, job history server. So that's what it looks like to the users. Cool. So what is the current state of REDstack at Target? So REDstack's currently our go-to development environment for both our team and users. We heavily leverage REDstack prior to any kind of a upgrade, especially a minor HTTP version upgrade. We're going to run through that upgrade hundreds of times on a REDstack environment before testing that in prod. We support multiple different HTTP releases. We have everything 2, 3, 4 and onward. We have over 500 cluster builds enterprise-wide. So all the teams and technology teams that have leveraged our team, there's been over 500 total cluster builds. We have over 100 active clusters today. So these are clusters that are actively running something within X amount of time. And we have many different stack types and the pluggability to add more, right? Let's say a new special cluster type comes out. We want to put that on the same infrastructure. It's pretty easy to just add that in to our existing REDstack platform. And then still back in with the original kind of goal of the project, we still have the ability to fully test our environment from scratch. So anytime we want to, as part of our CI, we can spin up an entire cluster, run smoke tests to validate it, make sure everything's running, and then spin that back down kind of whenever we need to. So kind of, I guess last year, we decided to rewrite some of the core code to open source it. So what this has, basically what we've changed is we've added pluggable modules, configs to swap out OpenStack providers so it can work with any of the public OpenStack providers or any other private internal OpenStack cloud. It's going to be fully customizable from a configuration file. We're not providing the GUI. We think it's easier to deal with configuration files. And we use a Docker image instead to isolate all the dependencies in place of the UI. We rewrote our internal cookbooks to be lighter weight ones that do things like set up a data node, set up a control node. And then we open sourced it through Target. So we have a blog post about it if you want to check it out. It's on our Target's external GitHub. And then here's some links to the repos here. Both of those will take you to the actual project themselves on the Target page in GitHub. All right, that's everything. Any questions?
Yeah, you said people aren't necessarily encouraged to use it for production, but that some might choose to.
Uh-huh.
What do you use to encourage people to roll their work back into your main cluster if they've chosen to go that direction so that you don't end up with too much sprawl?
Uh-huh. So it can be difficult to bring them back if they really want to stick with REDstack. And for some cases, like smaller Elasticsearch clusters, we see that it can work for, like, let's say they're using that as kind of just analyzing their logs and stuff. But basically, the biggest thing is we have this huge cluster and it has a lot more power. So if they want to use that and they want like the support of our team constantly looking at the cluster, they should probably productionize it through our production cluster.
Cool.
And I can add to that quickly. So the incentive is really scalability, like thousands of nodes cluster with hundreds of petabytes of capacity. That's what's really encouraging people to switch off of it. Once they test their use case, they know that they're going to scale and expand. And REDstack can only do so much.
Yeah, thank you.
So what are you doing when someone provisions a cluster and they're basically shooting themselves in the foot? They are screwing it up, and what happens with the data? Are you doing some backups of that data automatically?
So again, we kind of throw this out there. We have this big disclaimer on it. We're just like, we don't support this cluster. It's all up to you. If you want to use your root privileges and break your cluster, you can do that, right? So if they mess it up, they can rebuild it, but they're going to have to back up their data themselves. So we're not doing anything for users. This is kind of a fully self-service platform, so we don't want to get involved too much with stuff like backing up data.
Sorry, probably this question is based on my ignorance rather than anything else. So I got confused a little bit. When you started the presentation, you said you had a chef recipes. At some point, you referred to Docker images for bringing in pluggability. So suppose I have to add a new process, not Druid, something else, say Presto, I want to run it. So if I have to add it to your stack as a configurable thing, do you add a Docker image or do I add a chef cookbook?
So our infrastructure is built on Chef, so it would be a Chef cookbook to install a new
so
cluster
then
type.
where does Docker play? You said Docker images are used to.
Oh, gotcha. So you're talking about the Docker image for the, provide a Docker image that you can build, and it basically is just isolating the dependency environment so you can run the REDstack build itself from the Docker image.
Oh, it's for the REDstack itself. It's
Yeah.
not for the applications. Thank you.
Yeah.
Another question on availability of the cluster. So can anyone in the company basically request that cluster? And how many resources do you have available? Do you have kind of an upper limit on the number of clusters that you are able to provision?
Yeah. So
And how long can people use the cluster, basically? So, or in other words, what's the average usage time of that cluster?
So that comes down to the user. They're going to be requesting the cluster through the OpenStack team. I guess we're fortunate enough at Target to have a pretty open OpenStack team, and I've had no issues requesting like 2 terabytes of data just for a dev environment, and then leaving that running for a long time. Really, it just comes up to what the user is gonna request and what's gonna get approved. It's a pretty easy process. It's just a git pull request. I want X RAM, X CPU, and Z disk. So as far as them, how long they can have it indefinitely, or at least until that OpenStack environment isn't supported anymore. And even such, we've seen as we are transitioning through OpenStack releases, they've provided tools to kind of snapshot the images and then bring the whole thing over to the new environment. So we've seen people do that with REDstack as well. So I guess it can be there indefinitely, which is kind of the good thing about our internal private cloud.
How often do you recycle the clusters? You know, like probably somebody might have requested it like 90 days ago. If it's not being used, how do you monitor it and recycle them? And second, do you have any policy for the data governance on all those clusters that is being requested on REDstack?
Yeah, so we do have a monitoring script that basically reaches out and checks usage within the past X days. But historically, we haven't really been able to do much with that because it's not technically our resource. It belongs to a different team at that point. So when another team has their own kind of quota of OpenStack stuff, if they build a REDstack on it and then decide not to use it, that's up to them. That's the same as if they were to get a big OpenStack tenant and then build 18 VMs for no reason. That's on the user, right? They're just using our service to build those VMs. So in our eyes, that's between them and who's charging them for the quota.
To address the data governance part of your question, we don't do that intentionally because this is a sandbox environment. People can do whatever they want to bring in, delete, add, so we don't monitor that at all.
Does your production cluster also run on OpenStack? And if so, have you considered using this to split up production to avoid some of the scaling issues you're having?
So our production cluster is bare metal. It's all bare metal.
OpenStack is just kind of the other side of the data center. So we've been able to leverage them to help build smaller kind of dev environments. All right, I think that's it then. Thanks for coming, everyone.
Thank you.